Hello everyone, welcome to Dakshana e-classroom program. So in the last lecture, we talked about different types of LC, LR, RC series circuits, right? We saw like for solving such cases and we need one is phasor diagram. For drawing phasor diagram, you must remember the phase difference or phase relation between current and voltage across different elements, that is inductor, capacitor and resistor. So in resistor, the phase like both voltage and current are in same phase across the resistor. If I talk about inductor, then voltage lead the current by an angle of 90 degree. In case of capacitor, voltage lag the current by a phase angle of 90 degree. We also talked about the power in an AC circuit. So power in an AC circuit, we calculated average power. Remember, average power consumed in ideal inductor and inductor and capacitor, it's equal to 0. So means there is no power consumed. Only power consumed will be in resistor. So you can just simply imagine, if there is no resistor present in the circuit, then the average power will be 0, but instantaneous power is also consumed, like sort of you can say it's either stored and then released, that will be in inductor and capacitors. Remember, if it is asked instantaneous power, that normally do not ask or doesn't ask, so you need to keep that in mind. If it is asked, you need to deal it in different way actually. Okay, so average power we simply like calculated, that depends on basically finally comes out to be Vrms times Irms times cos of phi, where cos phi is termed as power factor of the circuit and phi is the phase angle between current and voltage in the circuit, right? So this is all about we talked in the last lecture. I hope you understand. Remember the things actually, like try to remember the phase angle, it's very important. Try to draw the phase diagram. Regarding phase diagram, I told you few things that you need to draw things, the quantity which is along x-axis, that should be constant through across all elements. So if you are drawing a phase diagram of series circuit, means in series circuit current is constant, so then we should consider current along x-axis. Similarly, if we are drawing a parallel LC, RC, RLC or any other parallel circuit, in case of parallel, what you can think, voltage across each element will be constant, so we should consider voltage across x-axis and then current. So based on that we will get same impedance and all that. Let's see, I will solve few more cases, few more problem. I hope things will make you these things will make you more clear. So let me just start with one more example, that is on calculation of power. And remember one more thing, if something is given to you, let's say V or I is equal to something I naught into sine of omega t plus phi something. In this situation, your I naught is the peak voltage and I is the instantaneous voltage. So it is given in terms of something sine of cos of omega t something. Similarly, if V is given as V naught sine cos sine, either sine or cos omega t plus phi something. Here also your V naught is peak voltage and V is instantaneous voltage. But if something is given like the way it is given here, okay, it's given there 225 voltage, I'm like simple voltage is or current is constant, that means that value will be by default RMS value. So remember that. Okay, so let me first solve on this problem. So find the average power consumed in the circuit if voltage applied. So here you can see the source voltage is given as 200 root 2 sine of omega t. What it means, this is V naught, this is peak voltage. Clear? Similarly, and current is also given to you directly, that is 2 sine of omega t plus pi by 4. So from here I can write V naught is equal to 200 root 2. This implies what is Vrms? So Vrms is V naught by root 2 and that will be 200 volt. Similarly, I naught is 2 and this implies Irms is equal to 2 by root 2, that will be 1 by root 2 ampere. And the phase angle, you can just see the phase difference between this and this, so I can write phi is equal to directly, is it coming out to be pi by 4. This is phase angle. Now we can apply the formula of power. Average power is given by Irms multiplied by Vrms multiplied by cos of phase angle. and you can substitute everything here. So 1 by root 2 multiplied by 200 multiplied by cos phi means pi by 4. Cos pi by 4 is equal to 1 by root 2. So 1 by root 2 multiplied by 1 by root 2, it's 2, and 200 divided by 2, you will get it's 100 watt. So you can imagine easily how easily we can get it. You just need to take care of the things actually that we need to consider here. RMS value or like peak value, that should be taken with proper. Is it? If you are doing mistake in that case, you will be doing like you will be getting wrong answer. So this is about one simple application of calculating average power. Let me tell you one more thing, like here one more problem. So let's read it first. A 9 by 100 Henry inductor and 12 ohm resistor is connected in series. So basically you can easily imagine it's talking about LR series circuit. This is the LR series circuit. It's connected across a source where like voltage is given 225 voltage and it's 50 hertz source. So frequency, and this is VRMS. Remember that. And L is given as 9 by 100 pi Henry and R is given as 12 ohm. Okay, so this is the AC source. Calculate the current in the circuit and plane phase angle between current and source voltage. So here we are asked to find current in the circuit and phase angle. Okay, so I can erase this question. Alright, so I think you can easily also think about that how we need to proceed. Is it? So for current you are given, first thing is VRMS, we can get IRMS, and what will be IRMS? So the magnitude IRMS will be equal to what? VRMS multiplied by Z. So means we need impedance of this circuit, and to calculate the impedance we must be knowing first let's calculate XL. So from here I can calculate the reactance or inductive reactance, that is given by what? Omega times L, and this omega is 2 pi multiplied by F, 50 hertz multiplied by L, 9 divided by 100 pi. So this is what? 100 pi cancel, it's 9 ohm. So this is your XL. Then I can easily get Z is equal to, because for this circuit we know the things actually, otherwise you can go with the phasor diagram also. Here what will be the case? This I will be common in both and you will get VR, and this will be your VL, and VL you can write IXL, and this you can write I into R. So net V will be along this, and from there we get actually Z. Impedance is coming out to be under root XL square plus under root R square. So from here I can write under root XL square plus R square will be your Z, and substituting the values, so it's 12 square plus 9 square, and this will be like 144 plus so this will be 81 under root 15 ohm, or like 15 ohm. Just check the calculation. So we got actually the impedance of this circuit. So next is the current in the circuit, that also we get. So current in the circuit, I hope you can understand. IRMS is given by VRMS divided by Z, and VRMS we have 225 divided by 15, so that will be equal to 15 ampere also, right? This is current in the circuit. Just check the calculation. And here the phase angle you should like write it from here. So you must be remembering this is phase angle because this is net V and this is your I. So the phase angle between these two is given by here. Now how we will calculate phase angle? So phase angle, you know, actually this quantity is what? It will be like IXL, or it will, you can write this will be also proportional to XL, and this is proportional to what? R. So here we can write the phase angle phi. So we will calculate here 10 phi. 10 phi is given by, you can write it either VL divided by VR, or that will be equal to IXL divided by IR. I gets cancelled. This is XL by R, and this comes out to be, XL is how much? XL we got, it's coming out to be 9, and R is 12. So this implies phi is equal to tan inverse of, this will be how much, 3 by 4. So tan inverse of 3 by 4, that is 37 degree. So this is your phase angle. Clear? So this way we can easily, like, if you're remembering the things properly, if you're not doing the mistake, I don't think like anybody should be facing any problem in calculating current, voltage, impedance, phase angle, or power consumed. Anything can be calculated very easily. Let's continue with the next topic here. So let me first erase it. Okay, so next here, just it's a small point about reading of AC voltage or measurement actually and current. First thing is, AC current and AC voltage is also measured by ammeter and voltmeter, just like your DC voltage and current is measured. But there is something different here actually, because in AC we have like two values. One is RMS value, another is peak value. So actually which value is measured by these instruments? So the thing is that these instruments work based on heat actually. So these are also called hot wire instruments. They work based on heat generated by voltage and current. So these are also called hot wire instruments. Hot wire ammeter or hot wire voltmeter. Hot wire voltmeter and hot wire ammeter. Right? So means in any circuit, if you are like something is connected and you are asked to find the reading of the ammeter, reading of the voltmeter, that means by default you are supposed to calculate the RMS value of current and voltage, not the peak value. The reading of ammeter and voltmeter will be the RMS value of current and voltage. So the reading of any AC voltmeter or ammeter will be the RMS value of voltage and current in the AC circuit. So these just few things you should keep things in your mind. Rest things are like just normal actually. There is nothing new about measuring. So whenever something is asked about calculate the ammeter reading, voltmeter reading, then you should just keep in mind is that these instruments work based on heating effect. So heating effect, we, like I just have told you, the effective value, and that comes basically RMS value. So that's why these instruments measure RMS value. So whenever something is asked to you about these things, measurement and all that, you are supposed to calculate RMS value. Let me just tell you one example here. Okay, so see one problem here, an alternating voltage V as source voltage 200 root 2 sine of 100t is connected to an 1 microfarad capacitor through an AC ammeter. Here it is also mentioned to you that it reads RMS value. It may not be mentioned always, so you need to keep that in mind. And what will be the reading of AC ammeter? So simply you are asked to find the reading of AC ammeter, means you are asked to find the current, but the current should be RMS current, not the peak current. So for this circuit we can easily get the RMS value of the current. So here we are given V0 peak voltage is how much? 200 root 2 voltage. This implies V RMS will be what? 200 root 2 divided by root 2. So this is 200 voltage. So we got the V RMS value. Now we also have frequency, that is omega t. So means I already have directly omega, that is 100 radian per second. Clear? Okay, then I need actually XC, reactance of the circuit, and that comes out to be 1 by omega into L, omega into C. And what is C? Yes, 1 microfarad. So it's coming out to 1 by 100, 1 microfarad minus 6. So this comes out to be, it's 10 to the power 4 ohm. So this is the reactance of circuit. Then what is the IRMS value? This is V RMS divided by X C. Right? and this is coming out to be 200 divided by 10 raised to the power 4. So that you can write 120 into 10 raised to the power minus 3, and this IRMS is equal to 20 milliampere. And this is actually the reading of ammeter, so I can write the reading of ammeter is given by 20 milliampere. Small thing, nothing complex, but need to keep in mind, right? That's the point actually here. If you are just forgetting that you are calculating simply I naught, you will definitely get wrong answer, and your answer will be wrong and marks will be also deducted. So just take care of few points, right? This is all about measuring instruments, AC ammeter and AC voltmeter. Rest remaining things you already know about it. Okay, let's see one more problem. These are all simple straightforward problem. Here I am trying to show you how to calculate different quantities. You must be familiar, so your focus must be to learn the approach, not about the problem, because it's not much complex and not much even important also, but from the concept point of view, how to calculate everything, it's important actually. So just focus on that how I will be calculating different quantities in such cases. Okay, so let me first explain you the problem. Here it's given in an RC series circuit. So it's given RC series circuit. The RMS voltage of the source is 200 volt and its frequency. So here it's given 200 volt, and it's even mentioned that it's RMS value. Even if it is not mentioned and it's given in this way, that means also it is RMS value. You should be having those things in your mind actually. Here it's mentioned, but even if it is not mentioned, then also you must be taking it as RMS value. That you should keep in your mind. And frequency is 50 Hertz. If R is given 100 ohm and C is given this 100 by pi microfarad. Now you are asked to calculate different quantities regarding this circuit. So let me first, so here you are asked to find first impedance, right? So impedance means you are asked to find Z, and Z in this circuit is given by R square plus XC square. So you have already R 100 ohm, we need actually XC. So XC is given by 1 by omega into C, and this implies 1 by omega is how much? It's 2 pi into this is 2 pi multiplied by F is 50 Hertz, and multiplied by C is 100 over pi. So this comes out to be how much? Pi gets cancelled, it's 100, so it's basically 10 raised to power microfarad. So minus, just wait a second, 10 raised to power minus 6, so then it will be 100 ohm. So we got XC. Now we can substitute everything there. Then Z is equal to under root 100 square plus 100 square, that would be your 100 root 2 ohm. So that we got Z. Simple, straightforward. B, the power factor angle. Okay, so that means it is power factor angle. When it is talking about angle, means that means you are asked to find the phase angle or phase difference between current and voltage. So that means it is talking about tan phi, and we know tan phi is equal to what? XC divided by R, and this is XC is 100 divided by R is 101. This implies phi is equal to pi by 4. And C part, power factor. So now power factor is what? Power factor, it's equal to cos of phi. Phi we already know, pi by 4. So cos of phi will be, I can directly write it 1 by root 2. Clear? Next case, current in the circuit. So current, okay, another thing is here it's mentioned simply current, so means which current you are supposed to find. If it is mentioned simple current, then also you are asked to find the RMS value, and that is given by VRMS divided by Z, and VRMS is how much? 200 divided by Z is 100 root 2. Clear? This is VRMS is 200, Z we are getting 100 root 2, so we will be getting its root 2 ampere. This is your RMS value of current. Next, maximum current. So maximum current means, now you can see easily, it means it's saying peak value of the current. So maximum current means peak value I naught, and that is equal to I RMS multiplied by root 2, that will be 2 ampere. Alright, voltage across resistors. So straightforward thing, voltage across resistor VR is equal to what? I RMS multiplied by what? And here voltage, simply it's saying voltage, so that means also you are asked to find the RMS voltage. So VR resistance across resistance is multiplied by R. So I RMS, how much we have? It's root 2. And what is R? R is 100. R is 100. So I can simply substitute 100 multiplied by root 2, that is equal to 100 root 2 volt RMS value. G, it's saying voltage across C, so that you can write again RMS value, and that is I RMS multiplied by XC. This is also exactly 100 multiplied by like this is XC, and I RMS is root 2, so this is also 100 root 2. Clear? And next it's saying maximum voltage across R. So maximum voltage across R will be what? Means its peak voltage. So its voltage is how much? 100 root 2. Then peak voltage will be what? This is VR. So I can write directly here, answer for this will be VR multiplied by root 2, so it's 200 voltage. Maximum voltage across capacitor means peak value of this, so this will be also equal to how much? 100 root 2 multiplied by root 2, it's 200 voltage. Now it's saying average power, okay, across resistor. Alright, I think there was one more case. So here it's talking about average power. Then average power, what we will write? Average power, I'm solving directly for this space purpose. So P average, you can write this is equal to what? I RMS into V RMS multiplied by cos of phi. Now you have everything. This is talking about for the complete RC circuit. I RMS, you have I RMS, max I RMS, we have root 2. And V already it's given 200, so I can substitute its root 2 multiplied by 200 IRMS VRMS IRMS VRMS cos phi value is also given, power factor, that is 1 by root 2. So this implies cancel, you are getting 200 watt. This is your average power in the circuit, right? Another thing, power across resistor. So let me write this J. Power across, average power across resistor will be equal to what? We will write it I RMS square into R. I RMS square is how much? I RMS is root 2. So this is actually 2 multiplied by R is 100. That means 200. Clear? Right? And what about like PC, average power? So that you should keep in mind automatically, that average power across capacitor is 0, because if you are talking about simply like for capacitor, when I am calculating, one more thing actually here, you calculate it this way. You can calculate if you are talking about average power across resistor, that will be also equal to V RMS across resistor multiplied by I RMS across resistor multiplied by cos phi. So now you should keep it in mind that what is V RMS across resistors? We have already calculated V RM. This is V RMS across resistor 100 root 2. I RMS, that will be same. So 100 root 2 multiplied by root 2. And because in resistor voltage and current both are in same phase, so means phi will be 0. So by substituting here, I hope things are visible to you people, otherwise I can erase it just a little bit here. Things are small, simple, but you should keep in mind, it's like if it is coming in problem, then you should not feel confused about these things. So here I am talking about average power across resistor, average power across resistor. It will be, can be I RMS square into R. Ideally it should be equal to V RMS, remember across R, I RMS across R multiplied by cos phi. Now here the cos phi will be the phase difference between RMS value across RMS value of voltage across resistor, IRMS across resistor. And we know actually in case of resistor, if I draw, then it's I and V both are in same phase, IR and VR. So this means phi will be what? 0 for only resistor. Then I can get VRMS. We have already calculated VRMS is how much? VRMS across resistor, this comes out to be 100 root 2. It's 100 root 2. IRMS is root 2, that means, and cos phi, cos 0. And from here also you are getting 200 watt. I hope you understood. Straightforward also we were getting, but you should understand the approach. The next part is K. So average power across capacitor. Now again it will be VRMS across capacitor, IRMS across capacitor, multiplied by cos phi, where cos phi will be what? Cos phi will be the angle, phase angle between this and that. Now here you must understand, this is for resistor. For capacitor it's IC, then VC is here. So the phase angle phi you can see is 90 degree. Then directly cos phi will be equal to what? 0. So you can get easily the average power dissipated across the capacitor is 0. So I hope you understand the different things actually that you need to keep in mind and how you need to calculate everything actually. So this is a little bit a small application of the concept that we have seen. Okay, next, it's a small concept that is called wattless current. Sometimes you are asked to find in different problem calculate wattless current. For that you must understand what is the meaning of wattless current. It's simple thing, let's listen it. So in one way I can define in a circuit, if R equal to 0, then by this time you must be clear that whatever the power is lost in the circuit, actually that all power lost only across resistor. Across the capacitor and inductor both, the phase angle is 90 and power factor will be 0. So power loss in a circuit will be 0. So I can write here, if R is equal to 0, this implies the power, average power loss in a circuit will be 0. Right? It will be either purely inductive or purely capacitive. So such circuit, is it, where power loss is 0 is called wattless circuit. Wattless circuit, and the current in this circuit is called as wattless current. Clear? So a circuit, if resistance in a circuit is 0, then also we can easily understand that there will be no loss in power. So such circuit is also called as a wattless current. A wattless circuit, and the current flowing in that circuit will be called as wattless current. Another way also I can define, or another way is that in general, let's say in any RLC circuit, is it, whatever it is, maybe RC, maybe RL, maybe LC, whatever the type of circuit, always I can write depending on, let's say this is V and this is I in the circuit. Then what I can write, this is the phase phi, phi is the phase, so V is the voltage across circuit, I is the current in the circuit. So you can say I am here mainly talking about series circuit. Even in case of parallel also you can exactly go, so voltage will be here and net current will be also coming at some point. So in that way it also satisfy condition for voltage like parallel circuit also. So in this, I is the voltage and phi is the, you can write, phase angle between I and V. Now what will be the power across this circuit? So I can write power, average power in the circuit is given by what? I into V into cos of phi. I am assuming these are my RMS values, is it? Or you can write it IRMS specially VRMS multiplied by cos of phi. I can understand it in different way. This is V, my I can resolve. So if write this, then this will be like component along this is I cos of phi. I am taking these, both are RMS value, and there will be I into sine of phi, right? So now you just look at it now. This is your net current. I resolve current into two components. Now you must be in confusion how we can resolve current into two components. I told you this is a phasor diagram. In phasor diagram we treat current and voltage both just like vectors, and there is nothing wrong in treating them like vector, because that is only termed as phasor diagram, where we can treat scalar quantities as vector. So there is nothing wrong, it's perfectly fine. So that's why I resolve I into two components. So this is I cos phi and this is I sin phi, right? Now you can see these two product will give you the power. Then what this current is doing? What this current is doing here? It's doing nothing. So you can say there is no power loss due to this current. Whatever the power loss is coming because of I V cos theta will be only like because of this component. So I can write this component of the current I sin phi is called Wattless current, right? So the component of current that is I sin phi is not responsible for dissipating of any power in the circuit, and it is called Wattless current. So it's just simple definition. You can look at this diagram, look at this circuit. If there is R coming, then means you need to find I current through the circuit and phi. So I sin phi will be your Wattless current. If there is no R in the circuit, maybe only LC circuit, or maybe only L, maybe only C, either condition, in that case simply get the current value. That current will be your Wattless current. Remember that in that case it will not be I sin phi. Exactly, if you calculate I sin phi, then also you will get exactly same thing, because in that case your phi will be 90 degrees, so it will not affect at all. So, or you can simply go in, if there is no resistance in the circuit, in that case whatever is the current is coming in the circuit, that will be your Wattless current. So I hope you understand this small concept that is called Wattless current. Okay, just see one simple case here. So if voltage of source is given, this is applied across an AC circuit and current through it is given by this. So here you can write the peak voltage V0 of the source is 200 and I0 is also given as 2 ampere. This is volt. Clear? So in a circuit you are given both I0 and V0, and here this is given phase of like voltage and this phase. And what is phi? You must be remembering the phi in this case is actually, if this is your I and this is your V, then this is your phi, and you can write this is, let's say, phi 1, this is phi 2, then phi is equal to phi 2 minus phi 1. Phi is the phase difference between I and V. It's not simply the angle of voltage or angle of current, remember that, or initial phase of voltage or initial phase of current. It's equal to this. Alright, so now here see we have what, like it's given, I can get phi is equal to how much? It's like pi by 3 minus pi by 6, that means it is pi by 3. So I got phi. I already have the value of current. So because it's talking about the RMS value, then I need to calculate first IRMS. That will be equal to what? 2 multiplied by IRMS is I0 by root 2. That means it's root 2 ampere. So this is the RMS value. Now it's talking about the Wattless current. So what is Wattless current? So I can get easily Wattless current will be equal to what? I, because it's talking about IRMS into sine of phi. You just need to calculate this. And remember, this phi is the phase difference, phase angle between current and voltage. So then it is root 2 multiplied by sine phi, sine of pi by, it will be pi by 6, pi by 6. Pi by 6 means how much? Sine 30. In sine 30 is 1 by 2. So it's coming out to be 1 by, I'm like root 2 divided by 2, that will be 1 by root 2 ampere. So this is the wattless current in this circuit. So whatever the circuit is given, you can calculate I, you can calculate V, you can calculate phi. Phi is the phase difference angle between I and V in the circuit or across the element in any circuit. Whatever it is asked, proceed accordingly. So I hope this all makes sense to you regarding wattless current. Okay, so the next topic we are going to discuss is choke coil. It's quite important, like small concept, but many times problems are asked based on like calculate some resistance, calculate inductance of the choke coil, something like that. Okay, I will solve some problem. So first thing is what it is exactly and why it is required. So let me try to explain you that. Okay, so let's say like in normal DC circuit, you must have seen if we have like some bulb and all that, is it? Fan, whatever it is there, and some resistance is there, R, and it's like resistance, that means like I can create one bulb having some resistance, so it's connected across some voltage, and the condition is that this resistance or this, let's say I will say it's bulb, is it? It has some rated power 100 watt and rated voltage of 220 volt. If it is connected across 440 volt source, definitely this bulb will fuse if you are connecting it directly. So what means we want to reduce the like current in this circuit so that voltage across this is not going beyond 220 voltage, or you can say we want to reduce the voltage across this, but voltage here we have is only 440. So what we can do is we connect one more resistor, is it? So this is our bulb actually, and we connect one extra resistance, and that way we will reduce the current. We will reduce the current such a way that voltage across this is not exceeding 220 voltage and everything will be fine. But the problem here is that what? In this case, a lot of energy will be lost in this resistor, and that's of no use. Understanding? If we are simply connecting a resistor in this bulb, then there is no use of this loss, it's complete waste. Lot of power or energy will be wasted across this extra resistance, right? Similarly, just look at it. So this is one DC. Similarly, if I am having one appliance, is it, which is being used and it's connected to some AC source, right, of resistance or impedance, let's say Z impedance, and it's some V0 sine of omega t, and exactly here also I want the current reduced across this, like I want to reduce the current across this, but I can't change this. Remember, you listen it properly, simple thing and interesting also. So here the thing is, this is like whatever the circuit here I have taken it like some, it seems to be like, or I will write simply one circuit having impedance Z, and it's connected across source, and some current will be flowing through this and some voltage potential drop, everything will be there. But I want to reduce, the objective is to reduce the current in the circuit. So what can be done for this case also? Yes, there are options to connect one resistance. If you are connecting the resistance, net impedance of the circuit will increase and current will reduce. So connect one resistance in series. You can connect in parallel also, no problem, but potential drop will not in that case will not change. If you require potential drop also to be decreased, that will. So if you want potential drop and current both to be decreased, in that case in the circuit you can connect one resistor in the series. Again, the problem here will be that some energy will be lost using here and a lot of energy will be lost in this resistance. Lot of energy will be wasted across R. Then what can be the better solution for this, so that we are getting the required voltage across this and required current in the circuit and still there is no power loss? And that amazing device is called choke coil. How? So choke coil is basically an inductor, and you must be knowing that in an inductor there is no power loss, but yes, it has some impedance or reactance. So if it has impedance and reactance, that means what? It will reduce the current, and if it is reducing the current, it will by default I into Z, it will reduce the voltage also. So it's working, it's fulfilling our requirement, right? And without like you can say least power loss, or you can say not at all. If I go for ideal choke coil, then it's like you can say the resistance of the choke coil is 0, so there is no power loss. But in practical, actually the real choke coil, it has some small resistance because it's a inductor made of some wire, so wire has some resistance. I hope you are getting my point, what I am trying to say you about choke coil. So choke coil here, if the requirement in the circuit is that we want to reduce the potential drop across this, or we want to reduce the current in the circuit, then we need something special element which is even not consuming much power. There is the loss in the power is minimum, and still we are able to do the task that was like to reduce the voltage across our element, across our system and current, and that can be done by using this. So choke coil, what it is simply an inductor or a coil wrapped around an iron, normally like a rod, and it form a choke coil. Its impedance, like I will say, its resistance is negligible, only it has inductance, so that way it produces, or like it means effectively it has some reactance. It help in reducing the current or voltage across the resistor, across the circuit, and that without wasting energy, or I will say the least energy is wasted. Let me write some like definition of it and a proper like a few points about it, then I will explain it. Okay, so choke coil, we can define it is a device having high inductance and very low resistance used to reduce the current in AC circuit, and that device is called as choke coil. This is also called ballast sometime in problem. So the like one of the application you might have seen is fluorescent tubes. Some tube lights are there, actually there choke coil is used, because in tube lights we need less small current, and that can be done by using simply one choke coil, and that too without wasting much power. So you already I think understood what is important, how it is like helpful choke coil. So and if you look at its construction, that how actually what it is made of, it is simply a copper wire is wrapped around a iron core, because the point is that we want L to be high, and L we know actually inductance, self-inductance from like our EMI chapter, that L depends on the material inside the like coil, is it? So if you want L to be high, then we need to like have a iron core in wrapped out. Okay, so this is our iron core, actually iron core. So that's why to improve or to increase L, to get high value of L, we are using iron core. If we don't need like let's say high value of the L inductance, we don't require much, maybe like in that case if frequency is high, in that case we can use even iron like air core also. So that is about. So the construction of the coil, the choke coil actually looks like this. There is a one copper wire wrapped around one core. That core may be air also if we need L to be low, and this system consists of called choke coil, right? So ideally we know actually that iron core like copper wire will have, and another thing is it will be laminated, otherwise the current will be passing between coil and all that, and that will be like even bigger problem. So it should be laminated. So next thing is the copper wire, it definitely will have some resistance, but in ideal case we take its resistance to be negligible or to be 0. So just like how it is connected, we connect normally this in series. So let's say this is a fluorescent tube or tube light, basically starter, that definitely might have seen, connected to some AC source. In this case we want like for current for this fluorescent tube or for this tube to be small, then we need to connect one choke coil here, and this switch, so when you are keeping it on, this coil will help in reducing the current. Some point about it, it consists of copper coil that you already understood, wound over soft iron, laminated core, laminated so that current is not passing between iron core and copper wire. Thick copper wire is used to reduce the resistance because we want the resistance to be least, is it, whatever it can, then of the circuit. Soft iron core is used to improve inductance, and that already you understood. And inductive reactance of choke coil is given by simply 2 pi f of omega into L. That's simple because choke coil ideally it is what, an inductor, and inductive reactance is given by XL is equal to omega multiplied by L, right? So that's what. And for ideal choke coil, you can say its resistance is equal to 0 and there is no power loss. That is only for ideal. In practical, a choke coil cannot have 0 resistance, but yes, ideal case we take it 0 resistance, and practical a choke coil is an actually R. It also has some R, it has some inductance, so it's an RL circuit. So I hope you must be clear about what is choke coil. Now you must be wondering what type of problem can be asked or can be framed on choke coil, is it? So that is also simple. If you understood the concept, I don't think you will face problem in solving problems or solving questions. Let me still tell you, and I will solve some problem example also, so that will make it even more clear. The thing is that, so in such circuit, maybe like some AC source is given to you, and we want, like, it will be mentioned that this is the source, and here impedance of this circuit is that, and then the current withdrawn, if you just simply go, then will be higher. So then you will be asked to find the inductance of the choke coil ideal, so that this is working perfectly fine. Means it is given some voltage or maybe current source, that much current will be withdrawn from here, but it is mentioned that across this you will require only that much, like small voltage or maybe some like less current, and that current need to be reduced by using choke coil. So then you will be asked to find the resistance or maybe inductance of the choke coil and something like that. So this is all about choke coil. Let me solve some problem based on it. You will be clear with that. Okay, so let's see some problem based on it, choke coil. It's not exactly on based choke coil, but yes, this type of model is also sometimes used. You must be understanding that too. So when an inductor coil is connected to an ideal battery of EMF 10 volt, right? 10 volt, a constant current of 2.5 ampere flow. When same inductor coil is connected to an AC source of 10 volt 50 hertz, the current is 2 ampere. Find out the inductance of the coil, right? First you need to understand the question actually. Here it's saying 10 volt, that means it's actually an DC source, ideal battery. So means when we are connecting an inductor coil to a DC source, what will happen? The current will be constant. Will inductor act or work like an inductor? Because you must be knowing, in ideal case, is it, or in steady state, if an inductor is connected to a DC source, what happened to it? It finally act like a wire. Just for the moment initially, till the time the current is not reaching in steady state or the circuit is not in steady state, it will offer some opposition, but once it is in steady state, because it's saying a constant current, means it's clearly mentioned, it's clearly given that circuit or coil is operated in steady state, so means only resistance part of the coil will work actually, is it? So when coil is connected to a DC source, only its resistance will be active, or you can say working. It will be working just like a resistance. So what is the resistance of the coil? I can write resistance is given by V over I, and that is equal to 10 volt divided by 2.5, that is 4 ohm. So this is the resistance of the inductor coil. Clear? I hope you understand this. Next thing is, when it is connected to an AC source, when connected to an AC source, Then coil also has resistance and it also has inductance. So which one will be effectively working here? You must be already clear about it. It must be impedance, right? So when connected to an AC source, its impedance is effectively active, right? And so if we are having one coil having inductance, resistance, then what is its impedance? Impedance is given by under root R square plus XL square, and XL is equal to omega times L, right? So we are already given RMS voltage and the current. So I can get the Z impedance is given by V RMS divided by I RMS, and that comes out to be 10 divided by 2, it's 5 ohm. So I got the value of Z, impedance of the coil, and impedance is given by this, so I can substitute here. So this implies 5 is equal to, from there this circuit, 5 is the impedance under root R, that is 4 square plus XL square. 25 squaring both side, 16, then XL will be, this implies XL is equal to 3 ohm. And if I have 3 ohm XL, then it's asked about inductance of the coil. I'm solving it here. I will, using this space, I will remove it. Okay, so I got XL, and you know the already XL is equal to what? Omega multiplied by L. So L is equal to XL divided by omega, and that is XL is 3 divided by omega is 2 pi F is how much? 50 hertz. So inductance of the coil is 3 divided by 100 pi Henry. This is about this problem. I hope it makes sense to everyone. Simple thing, when an inductor coil is connected to a DC source, effectively it's acting like simple or pure resistor. So we can get its resistance 4 ohm. When it is connected to an AC source, then both resistance and inductance both are actively participating, or you can say effectively active or working. So in that case, your inductor coil is acting like an one impedance, or its impedance will be active. So I can get impedance is equal to V RMS divided by I RMS. I got the impedance, and impedance will be like, if a coil is there, then impedance is equal to what? It's given by under root R square plus XL square. R is its resistance, XL is its reactance, and I got Z. I have this. Simply by using this relation, we are getting XL. Once we have XL, then we can get XL is equal to omega times L. Omega we are already given with that, so we can substitute the value, and this is our inductance of the coil. So that is this problem. Let me solve you next problem. Okay, so let's read the problem. A bulb is rated at 100 voltage, 100 watt. So bulb rating 100 voltage, 100 watt. It can be treated as a resistor, so means it's having some resistance. Find the inductance of the inductor. Inductor means it's given as choke coil. That should be connected in series with the bulb to operate it at its rated power with the help of an AC source of 200 volt. And so AC source how much? It's 200 volt RMS value and 50 hertz. Is it? Okay, so first thing is, let me check something. Here rated bulb has rated voltage and power. So resistance can be calculated V square by P, and that means 100 V is equal to, like, P is equal to V square by R. So we get 100 divided by this 100 square divided by 100, that would be 100 ohm. So this is the resistance of the bulb. Alright, so let's just say for a moment, if I do not want or another thing is, if we want to operate it at 100 volt, 100 watt power, then what should be the current? The current through R to operate at rated values, so that I can write V is equal to I into R. V is how much? 100. I is how much? Like I don't know, R is also 100. This implies I am getting 1 ampere. So means if you want to operate it at this rated voltage and rated power, then the current through it should be 1 ampere. Alright, let me check if I am not using any inductor, then what is the actual current through it. So then you can write, if no inductor, if no coil is used, right, then you can write I is equal to what? V RMS divided by R, because it's only resistor, and VRMS is given as how much? It's given mentioned as 200 divided by 100, it will be a 2 ampere. So that's a problem, because 2 ampere cannot operate it at this requirement. Clear? Then we need one choke coil, right? So to operate it at this rated values, what we need, the current through this should be 1. VRMS already given, so let's calculate the impedance of total circuit, is it? So to operate the bulb at rated values of 100 volt and 100 watt, IRMS should be how much? 1 ampere. Then let the impedance of circuit required, I can calculate IRMS is equal to VRMS divided by Z, that is equal to 1 equal to 200 divided by Z. So that implies Z should be how much? 200, right? And Z will be equal to, we are now using inductor coil, so then Z is given by under root R square plus XL of inductor, and Z is equal to how much? 200. R is equal to under root 100 square plus XL square. Simply squaring both sides, it will be 400 minus 100 like square. So then XL square we are getting is equal to 440 minus 1 and 40, that is basically 3 into 40, and this implies your XL is equal to 100 root 3. I hope you understood. This is XL. Then what is XL? XL is equal to omega times L, and omega is 2 pi into F. F is 50 multiplied by L, and that is equal to 100 root 3. So this 2 pi and this is gone. This implies L we are getting root 3 by pi Henry. So means you need to connect a choke coil of having inductance root 3 over pi Henry. I hope this problem makes sense to everyone. What exactly the question is, what it is asking us to find the inductance of choke coil. That's application of the concept that we have just learned, choke coil, and how to approach, how to proceed, everything should be clear. So this is all about choke coil, right?